Okay, guys, good evening. Today I want to take you through vector analysis, and the vector analysis I want to take you guys through the three formulas, the so-called frenet-serret equations. Okay, let me start off. We have the frenet-serret equations or formulas. Let me use the word formula. These formulas are three in number. We have one. The first formula, it is d of t over d of s should give you k of, I think it's k of n. This n is a vector, this t is a vector. We have the second one. The second one, it is d of b over d of s. I think from the book that one should give you d of b over d of s should give you negative torsion n. And the third formula, the third one, it is d of n over d of s, which should give you torsion d minus constant t. Those are the three formulas. Now let me start off. In high school, we were taught the two planes, the x and the y plane. This one. These are y and these are x axis. But here, if you want to find all these three, we have to add another plane, which is the z plane. The z plane. Okay, from this point, the frenet-serret equations, we have to draw a curve so that we can find this t. This t is the tangent, this vector t is tangent. Now, if I draw any curve here, like for example curve S, and I have this point here, I want to find a vector along this point P. I have to find at this point, the vector at this point, I have to draw a tangent through that point, a tangent t. That's my tangent. And because we're dealing with vectors, now this tangent, I'll show that it's a vector. Okay, on this tangent, for example, if you want to find the equation of a line, you have to, on this equation, on a tangent, you have to find the equation of a line or a gradient, you need to find the normal. And the normal, it is always perpendicular to that tangent, but at that point. So if I draw the normal is n, which is a vector also. And this n, it is perpendicular to this point and to this tangent at this point. But from your eyes, you can see that this tangent, it is parallel to the x-axis, and normal, it is parallel to the y-axis. Okay, the tangent and the normal provide another one. This is the binomial. Now, I have to look at the trigonometry. We were told that if you move with a vector or with an angle in an anti-clockwise direction, you always add, those angles are always in positive, with the positive inversion. And when you move in clockwise direction, they usually give you the negative angles. Now, let me find these equations now. In vector, we are told that if you dot a unit vector by itself, you get 1. I want to find this vector 1, and I'm dotting this t by t. If I dot this unit vector, I'll get 1. But I want to differentiate this t. So if I dot t by itself, I get 1 because these are dot product. Now, if I want to differentiate, because I want to find the t over the s, I'll have d over the s of the dot product of these two, which is t by t. It should give me 1. And if I differentiate on this side, I also supposed to differentiate on the other side. So I also have equals to d over ds of 1. Okay, we have dot product. We have to use the product rule. Product rule, we hold the first t and we differentiate the second one. So I'll have t dot d of t over d of s. You have to show it's a vector. Then we differentiate the first one, we hold the second one. I'll have dt over ds dot t. This should give me the d over ds of 1. If you differentiate a constant, you get a 0. Now I'm having a dot product with the common. It means a dot b. It's always equals to b dot a. This shows that these are commutative. It's commutative. So it means that t dot dt over ds plus dt over ds dot t is the same. So I'll take 2 of t dot dt over ds. It should give me 0. But this 2 is a number. 2 can never be equals to 0. So what is equals to 0? It is t dot dt over ds. It is equals to 0. And if you dot a vector by itself and you get 0, it means that this vector is orthogonal. When it's orthogonal, it means that dt over ds, it is perpendicular to this vector t. Let me come back to this structure of mine. This is my vector t. A vector that is perpendicular to this t, it is this one. It is the vector dt over ds. And if this one is perpendicular to this vector, and normal was also perpendicular to this vector, it means that dt over ds, it is parallel to this normal. It is parallel to the normal vector. And I want to move this parallel side. If I want to move this parallel side, what will I do? This is what I will do. I'll have v of t over ds. This normal side, this parallel side, I'll equate with the equal side. Then I'll improvise a constant which is k. This is my first equation of frenet-serret equation. I've proven that dt over ds is equals to k of n, of which this k is a constant. Now my k, this k of mine, it is known as the curvature. And we have another version which is r, not r, I mean rho. Rho, it is the radius of curvature. I think that is the first frenet-serret questions. Let me look at the second frenet-serret question. Okay, the second frenet-serret question, it is this one, dv over ds, and this one is a vector. Which it means that I'm differentiating v, the vector v. I'll have this v here, this v, I mean. And b, from this side, this b, it is given by taking the value of t, multiplying by, crossing by the value of n. So b is equals to t I cross with n. It means if I want to do the d of b over the d of s, I'll have to do the d over ds of t cross n. On this side, this is a product rule. I have to use product rule. And product rule, it means I'll have the first one, that is t, then cross dn over ds plus, I'll differentiate the first one as well as the second one. It will be d of t over d of s cross by n, by vector n. And if I'm having this one is the same as d of b over d of s. Okay, from the previous one, we had our value of dt over ds, this one. So you have, but d of t over d of s, it is equals to kn. We had it like that one. So I'll have it that d of b over d of s is equals to t cross d of n over d of s. Then I'll add to d of t over ds, it is kn. So I'll have it as k of n cross n. These are scalar. I can put the scalar outside. So I'll have t cross dn over ds plus k into n cross n. And if I cross a vector, if you cross a unit vector, you get a 0, a constant. This is crossing, not dotting. So this one is 0, and 0 multiplied by constant, you get 0. So this value gives you 0. I'll have d of b over d of s is equals to t cross d of n over d of s. So reaching at this point, I'll have to dot both sides by t. So I'll dot this side by t and the other side by t. I'll have t dot db over ds should be equals to t dot t cross the n over the s. Now, if you dot a unit product, a unit vector, you get 1. Now it means I'm having t dot db over ds should give you 1 of this one. Now it should be d of n over d of s over 1. This one, if I differentiate this one, I'll get 0. So on this side, all of it I'll have 0. So I'll remain with t dot d of b over d of s, which will give me 0. Giving me 0, it means that I'm dotting two vectors. I'm dotting two vectors and I'm getting a 0. It means that these vectors are orthogonal. If they are orthogonal, it means they are perpendicular to each other. So I'll have d of b over d of s. It is perpendicular to t. And this t, I come back to the structure. This is my vector t, the tangent. The vector that is perpendicular to it is this vector. It means this vector is parallel to vector n. So I'll have it as d of n, d of b, I mean, d of b over d of s. It is parallel to vector n. This vector being parallel to vector n, it means that d of b over d of s, it is equals to, now I'll have to choose another different constant, which is negative of torsion of n. And this is the second frenet-serret question. I've confirmed it. Now I still have the third one, which is the most simplest one. Let me go through that one. Okay, the third one, it's d of n, it's a vector, over d of s is equals to this one. Now that means I have to differentiate this vector n. Let me come back to my structure. N is here. If I want to get this n as positive, the way you've been given, I'll take the b, I'll move in anti-clockwise direction so that I can get the positive one. I'll take the vector b, cross multiply with the vector t. So this n will be equals to b cross with the t. Now getting d of n over d of s will be equals to d over d of s of b cross t. And this I'll apply product rule here. Product rule, it means I'll hold this b and differentiate the second one. So I'll have d of n over d of s is equals to b cross d of t over d of s. I'll add 2. I'll differentiate the first one and hold the second one. I'll have d of b over d of s cross with t. This is what I'm having. But I had d of t over d of s as kn. And I also had d of b over d of s as negative torsion. It was negative torsion. Now this was the value of d of b over d of s, and this was the value of d of t over d of s. I'll come and insert them in the equation. I'll have d of n over d of s is equals to, my b will remain vector b cross with dt over ds, it is kn. Then plus db over ds, it will be negative torsion n cross t. Now this k is a scalar. I can take k outside and remain with the vectors inside the bracket. I'll have the n over the s as k into b cross n plus this torsion. This is a scalar. It is also a scalar. I can take it outside. I'll have negative torsion into n cross t. This b cross n, if I come back to my structure, I'm having b cross n. This is clockwise. If it is clockwise, it gives a negative value. Now b, if I cross with the n, I'll have negative t, which is negative vector t. So this d of n over d of s is equals to k multiplied with negative t, negative vector t. Then plus this negative torsion into n cross t. N cross t. I'm also moving in clockwise direction, which means I'll have a negative value of b. So it will be negative b. I can finally it out as d of n over d of s is equals to, this one I'm having as a negative kt. Negative and negative gives me a positive. So I'll have plus torsion b. And this one I can start with a positive and end with a negative. I'll have d of n over d of s is equals to torsion b minus constant t. And this is my third frenet-serret questions. I think I'm done with the derivation of the three formulas, and if you can have any question, you can just contact me. Thank you.